Hi, my name is Max Awtry, and this is my launch angle study. So, a little bit about why I chose the topic I did. So, I wanted to choose something I was passionate about, and baseball is something I've played since I was a kid, and it's really what me and my brothers were raised on. Everything we did was baseball related. We spent so much time at the baseball field, and that's still pretty true to this day. Both my brothers went on to play college baseball, and next year I'll be playing baseball at the Naval Academy. So, what is launch angle? So, launch angle is described and defined as the vertical angle that the ball makes when it leaves the bat. So, the ball will come in along the blue line, which we refer to as the x axis, and it'll leave along the y axis. And that angle is what we call the launch angle. So, my objectives. Well, first, uh, the reason why I'm focusing on launch angle is because there is a hot debate amongst the baseball community right now about if you should swing up or if you should swing down, and that's measured through launch angle. Um, and I wanted to see first and foremost which has the most science behind it. I wanted to explore personally where my swing fell, and my original hypothesis was that my optimal launch angle will be 15 degrees. And then lastly, I wanted to analyze the data I collected to help further my hitting abilities and help further my knowledge. So, swinging up. When we're talking about swinging up and swinging down, it's important to talk about the scale that we're using. So, 10 to 25 degrees, that's considered a line drive. 25 to 50, that's considered a fly ball. And 50 and up is considered a pop up. So when we're talking about swinging up, we're looking at that 25 to 50 degree range. That's considered swinging up, and the 10 to 25 is considered swinging down. So let's look at swinging up when we're talking about this chart. So this is a hit probability chart in regards to launch angle. So let's focus on the 25 to 35 degree area. So if you look at the 35 on the left and you follow it across, you'll see that you'll hit some pretty heavy red areas, which is the highest hit probability areas. And it's pretty evident that while it is still high when you get the 0 to 10, 10 to 15, those are still pretty dark red, but the darkest of the reds is that 25 to 35 degree range. So the 10 to 25 degree range is what we refer to as swinging down. So let's take a look at that in regards to percent of batted balls as hits. So in the 19 to 26 degree range, we see 52.7% of batted balls become hits, which is pretty good. When we increase to up to 30, from 25 to 30 degrees, we see that we have a decrease in percentage of batted balls becoming hits. It goes from 52.7 to 43.1, which is pretty severe. So when I synthesize everything that I researched, it comes down to this. Swinging up and swinging down are both effective, and they've proved effective for many players and many organizations. Many players think swinging up is great, and that's how they think about it. And many players think swinging down is great, and that's how they think about it. It really is on an individual level, and it's really a preference and a organizational thing that it boils down to. So, if you want to find out which launch angle is most effective for you, you have to take exit velocity into account. For example, if you're hitting the ball at 25 degrees and you're hitting that at 70 miles per hour, that's going to be an out every time because it's going to go right to the outfielders. But if you're hitting the ball at 25 degrees with an increased exit velocity of 100 miles per hour, that's going to go out at just about any ballpark. So I wanted to put what I researched to the test, and I wanted to see how my swing correlated and where it fell on the spectrum of what I had researched and swinging up or swinging down. So here's what I did. I did 65 trials. And how I collected my data was I collected the launch angle and I collected the exit velocity. So you can see here, I measured the ball coming in along the x-axis, and I also measured it leaving along the y-axis, and that gave me my angle. And the pocket radar gave me my exit velocity. And that pocket radar is extremely accurate. It's extremely effective, and it gives very, very accurate readings. So shout out to Mr. Willis and Mr. Bennett for helping me get that, because, like I said, it's very hard to measure the effectiveness of a launch angle if you can't use exit velocity to help you along the way. So I wanted to try and isolate launch angle as best as I could, and I thought it was fitting to use the projected average as a good way to tell where my launch angle was effective. So you can see the peak of this curve. If you look at the peak of the curve and then you follow it down to the x-axis, you can see that it actually does fall right about in the middle of the 10 to 20. It's leaning closer to 20, so we could call it 14 to 18. That seems like my window for my launch angle where my projected average is the highest, which is a good way to measure effectiveness in a swing when you're talking about the high school and college level, because at that age and at that time, it really still is a team sport, because no one out there is getting paid at the college level, at the high school level. It's really just about winning, and it's really about helping out your team. So, like I said earlier, you need to measure exit velocity if you want to find out where your launch angle is most effective. So I try to focus on my hardest exit velocities, because that's ultimately what you want. You want to hit the ball as hard as you can. So my three hardest hits were at 90 miles per hour, 90 miles per hour, and 91 miles per hour. So these exit velocities were paired with a launch angle of 6 degrees, 2 degrees, and -4 degrees. With these exit velocities and launch angles, my projected averages were 509, 294, and 494. So I played around with it, and I increased my angles to 15 degrees while keeping those same exit velocities. And with that alone, I saw almost a 40% jump in my averages, going up to 880 and 980. So I thought these were extremely effective visuals to help get an understanding of kind of what we're talking about. So on the left, you can see it says my exit velocity of 84 miles per hour and a launch angle of 17. So I use those two numbers because those were the average of my 65 trials. And while 65 trials is not a ton, I was aiming for around 500, but I was early on in the process. I was told I had to get hip surgery, so that kind of put a halt to that, because I couldn't be swinging like before surgery, and I definitely can't be swinging after surgery. So that's why the 65 trials, is what it is. But I was still able to find a decent amount about my swing just from those few amount of trials. So what you can see on the left is a batting average of 894, which is good because some of the best players in baseball, while they have way more than 65 swings, their averages are about 300. So this is pretty good on track for just practice numbers. But you can see a lot of them are orange dots, and those orange dots are singles. And ultimately, you want less singles and you want more doubles and triples. So on the right, I manipulated it and made the exit velocity 90 miles per hour, and I made the launch angle 15 because that was my optimal launch angle, and 90 seems like a reasonable number for those 65 trials because that was some of my peak exit velocities. So you can see an increase in doubles. You can see more purple, which is really what you want. Ultimately, it would be nice to see some more yellow. And hopefully once I get healthy and can do this again, I will see some more yellow. So my conclusion is that looking back on my first hypothesis, it seems a little naive because I was just trying to isolate my launch angle without talking about my exit velocity. So my kind of new statement is that my optimal launch angle is 15 degrees when paired with an exit velocity at least 90 miles per hour. Also, this research and collecting this data and understanding my swing has helped me realize that I was kind of focusing on the wrong thing. If you really want to increase the productivity of your swing, you need to increase your exit velocity, and then that allows you to swing more freely in terms of launch angle. Because if you're hitting the ball at 5 degrees, but you're hitting it over 100 miles per hour, your hit probability still goes way up. And same with 25 or 35 degrees. If you're hitting that over 100 miles per hour, that's going to be a home run at about every ballpark. So it's really helpful to help me lead myself into a different type of training that I hadn't really focused on before. Thank you.